All right, good morning. Today we are going to go over how to do a contact tracking MoBoard. Before we jump into the MoBoard, I want to go ahead and remind you of some formulas that we will be using throughout this curriculum. First one being target angle. The formula for a target angle is the true bearing of the contact minus the true course of the contact plus or minus 180 degrees. Remember, the answers for target angle will always be in degrees relative. Second formula that we're going to use a lot is the formula to convert relative bearings to true bearings. So that one equals true bearing equals the true course of own ship's heading plus the relative bearing. And that's how you'll be able to convert a relative bearing that could potentially be given in the problem to a true bearing so that you can plot it on your MoBoard. So our problem that we are going to be starting with today is at time 0800, a contact bears 280 degrees true at a range of 16,000 yards. At time 0815, that same contact bears 300 degrees true at a range of 10,000 yards. You are on course 135 degrees true at 15 knots. So when we're doing our MoBoard, first thing that we want to do is go ahead and plot all of our knowns and unknowns. So our first known is going to be the bearing and range of that contact or that maneuvering ship. I will use the words maneuvering ship and contact interchangeably throughout all of these videos, so I just want you all to be aware of that. So if we know that our initial sighting of that contact was at a range of 16,000 yards, that lets us know that we are not going to be able to use that one-to-one scale. 16,000 yards is larger than our one-to-one scale. Remember, our one-to-one scale only goes up to 2 to 10,000 yards. So we're going to go ahead and use our 2-to-1 scale. When you're doing a MoBoard, you always want to remember to circle the scale that you are using so that you do not forget it towards the end of the problem. Because if you start mixing and matching scales, then you won't get the right answer. So we're going to take our dividers. We are going to measure out 16,000 yards using our dividers. We are going to come to the center because remember, everything measured out of the center is going to be true, and we were told that the contact bears 280 degrees true. So we are going to find the bearing of 280 degrees true. That's 16,000 yards, and we are going to make a dot right there. This dot is going to be our M1. That is the initial sighting of that maneuvering ship. Next piece of information that was given to us is the second sighting of that contact, which was 10,000 yards down a bearing of 300. So I'm going to take my dividers, measure out that 10,000 yards, beginning at the center, because remember, everything from the center is true. Find that bearing of 300 degrees true. I'm going to make a mark there. This point represents that second sighting of the maneuvering ship. That's what M2 is. Our last known is our course and our speed. So like I said before, our course and our speed. When you're doing a MoBoard, if you were dealing with a speed, so that's anything ending in the unit of knots, you are going to come over to your 5-to-1 scale. So what I like to do is I like to write the word speed next to my 5-to-1 scale so that I can always remember if I'm dealing with anything in knots to bring it over to my 5-to-1 scale. So I'm going to take my dividers and I am going to go ahead and measure out 15 knots. I am then going to bring that 15 knots over to the center of the MoBoard, and I'm going to make a mark down the bearing of 135 degrees true. Once I have that mark there, I'm going to line up my weems with that mark that represents that 15 knots, and I am going to draw a line. This line represents This line represents my ER vector. So if this is down my bearing of 135 degrees and I go up through the center, this line right here is representing my ER vector. Remember, ER is the reference ship's true course and speed. So now that I have all of my knowns, which is my initial sighting of the maneuvering ship, my second sighting of the maneuvering ship, and my course and speed as the reference ship, I'm gonna go ahead and plot out what my unknowns are. So that first unknown that I'm going to be looking for is my DRM. That second unknown is my MRM. Remember, your DRM is the direction of relative motion, MRM is the measure of relative motion. Third unknown is your SRM, which is your speed of relative motion. Lastly, we want to be able to plot out our EM vector, because from the EM vector, we're able to find the maneuvering ship's true course and true speed. So now we have all of our knowns and our unknowns plotted out. Next, we are going to, our first unknown that we're going to solve for is our DRM. In order for us to do that, we have to first connect our M1 to our M2 in the direction that they are actually traveling. We are then going to take our weaves, drag them down to the center. We're going to draw a line in that same direction, and then we're going to bring that down to the tip of our ER vector, and we are going to draw a third line in that same direction. So this first line, that is showing their relative motion. So that's going to be our line of relative motion. And what that is telling us is that the ship was here, and then it was here, so that means that it's traveling along this path. That is the path of their relative motion. So we're gonna go ahead and label that as our LRM. This line here, this middle line that's coming off of the E, this is their direction of relative motion. So that's letting us know in what direction they are traveling. This bottom line here, I call that my RM line of possibilities. What that means is somewhere along this line, I will be able to find my point M that I need in order to complete my speed triangle. So, in case you didn't catch it, we already found our first unknown. We found our DRM. So wherever this line intersects with that outer bearing ring, that is going to be your direction of relative motion. So I got 073 degrees true. You always want to make sure that you are writing the proper unit, because if you do not write the proper units, no one is going to know what you're talking about. It's just going to be a random set of 3 digits. Once you write that degrees true, it's letting us know that this is the true direction of relative motion that that ship is traveling. Next thing that we want to find is our MRM, or our measure of relative motion. So we want to figure out how much distance passed between the ship, the maneuvering ship being here at M1 and then being here at M2. So all we're going to do is take our dividers and we are going to measure out the length or the distance between M1 and M2. We are going to bring that over to our 2-to-1 scale. That's going to give us a measure of relative motion. So I got 7,400 yards. So what that means is between our initial sighting and our second sighting of that ship, they traveled a total distance of 7,400 yards. Our next unknown is our speed of relative motion. So I want you all to think back to your time, speed, distance equation, and I want you all to think about the variables that we have and the variable that we are looking for. So if we're looking for a speed, we need to have distance and time. So we already have distance. We know how far it took them to travel between M1 and M2. That was that total of 7,400 yards. Now let's think back to the original problem that was given to us. They let us know that between M1 and M2, a total of 15 minutes passed. So we have all 3 variables. So all we're gonna do is come down to our nomogram. You're gonna plot time on that first line, so that time of 15 minutes, which came from the problem. our middle line, or our second line, is the distance line. We're going to plot that distance of 7,400 yards, and then we're going to connect the dots. So when we connect these 2 points, or these 2 lines, we get a speed. That speed is 15 knots. So what that means is, between that ship, that initial sighting of that ship, and that second sighting of that ship, they traveled a total distance of 7,400 yards in 15 minutes at a relative speed of 15 knots. So our SRM is 15 knots. So now we have a speed. Remember, when we have a speed, we're always going to come over to our 5-to-1 scale, or our speed scale. So we are going to take our dividers. We are going to measure out 15 knots. We are going to bring our dividers over to the tip of our ER vector, and we are going to make a line where it intersects with our RM line of possibilities. So this point is your point M. So now we have our E, R, and M. So we have all 3 points that we need for our speed triangle. So all we're going to do is use our weaves, line them up through the center and point M. We are going to draw a line, and we are going to see where that line also intersects our bearing circle. So now we have our ER vector, our RM vector, and our EM vector. Wherever from this EM vector, remember, we're able to find the true course and the true speed of the maneuvering ship. So looking where this EM vector intersects with that outer bearing ring, that lets us know what the true course of that maneuvering ship is. So for my true course of the maneuvering ship, I got a measurement of 104 degrees true. I'm going to go ahead and write that down next to the course for the maneuvering vessel. Now I need to figure out their true speed. So I know what course they are actually traveling, what course they have ordered up on their ship. I now need to figure out what speed they have ordered up. So all I'm going to do is take my dividers. I'm going to start at the center. Remember, I'm looking for a true speed. Everything from the center is true. And I am going to measure out the distance of this EM vector. I'm looking for speed, so I'm going to bring it over to my speed scale, or my 5-to-1 scale. And I'll be able to get a speed from that. So I have mine crossing at 26 knots. So I have this maneuvering ship traveling at a speed of 26 knots. So now we have solved for all of our unknowns. I want you all to keep this MoBoard because we are going to use the same MoBoard for our CPA problem.